Hello and welcome to today's webinar, Near Infrared Spectroscopy Applications for Ethanol Production. My name is Karen Whitman and I will be the moderator of this webinar today. Before we start the presentation, I have just a couple of housekeeping slides to go over. This webinar is recorded and the recording will be available in 1 to 2 days. All questions will be answered at the end of the presentation. If for some reason we do not get to your question, the presenters will email you with an answer to your question in the next couple of days. As questions do come up, click on the questions section of your webinar panel and then just write your question in the text box that's available. And then any questions that are in the queue is the questions that we will answer at the end of the presentation during the question and answer section. It is now my pleasure to introduce to you Karen Gerwitz and Dr. Cheng Hussein. Karen Gerwitz has 19 plus years of experience in quality assurance and product testing in the food and consumer products industries. She specializes in delivering instrumentation solutions and is a veteran in implementing customized infrared solutions for both mid-infrared and near-infrared bench-top and inline testing systems. Prior to joining the Eurofins team 2 years ago, Karen held previous positions with Vero Verstes, ConAgra, and Buffalo Filter. Karen is an active member of ASTA, the American Spice Trade Association, and NDB, the National Biodiesel Board. Karen holds a Bachelor's of Science in Biology from the State University College at Buffalo, in conjunction with the University of Georgia. Our second presenter today is Dr. Cheng Hussein. Dr. Sang has more than 30 plus years of expertise in spectroscopy technology. He has been the pivotal point in the implementation of the NIR infrared technology global-wide at Cognis Corporation. Rooted from his vision to deliver robust and highly rugged near-infrared systems, he has earned several patents on method development, sampling systems, and QTA's concept. Dr. Sang's leadership forms the cornerstone of QTA's success on delivery of the promises of infrared analysis. Methods for the biodiesel industry are accepted as the AOCS CK209 official methods and the alternative ASTM methods. Dr. Sang has profound knowledge and expertise in dealing with the most challenging NIR applications in numerous industries and has developed thousands of algorithms. Dr. Sang is a regular contributor of books, chapters, and journals. Dr. Sang holds a PhD in analytical chemistry with specialties in spectroscopy and chemometrics from Florida State University. It is now my pleasure to hand over the floor to Karen for our presentation portion of today's webinar.
Thank you, Karen. Well, I will get started with a brief overview of the Eurofins team. With more than 22,000 employees across more than 225 sites in 39 countries, Eurofins is a leading international group of laboratories providing an unparalleled service to the pharmaceutical, food, environmental, and consumer product industries. As you can see from the lower right-hand images, the dots represent the locations across the U.S. on the left, and then on the right, the global locations, and then in the middle, the focus in Europe. So QTA stands for Quality Trait Analysis, and we were once part of BASF, the chemical company, until about 4 years ago when Eurofins acquired us. QTA focuses on both near and mid-infrared solutions. For our agenda for today, we will talk about the fundamentals of infrared technology, both the pros and the cons, applications, Some things you need to consider for a successful infrared program, some of the inherent challenges to overcome. We'll also talk about QTA's patented technology surrounding infrared solutions. We'll talk specifically of areas of application for a QTA system, and then we'll have time for the question and answer session. So as the basic principle of the infrared spectrum, infrared spectroscopy refers to the infrared region of the electromagnetic spectrum that is light with a longer wavelength and lower frequency than visible light. So when a sample is subjected to a light source, the light is either transmitted through or it's reflected off of the sample, which can create a spectrum for that particular sample, which can be used for fingerprinting. So near infrared can be used for both quantitative and qualitative analysis. So let's focus on quantitative, or the determination of chemical composition or chemical properties of a material. As a first step, the calibrations need to be created. So using primary test methods and then collecting spectra via near infrared, then applying chemometric modeling to develop the model. Now using the chemometric model, future samples can be analyzed more quickly and easier than the traditional or primary method. In the bioethanol production industry, traditional analyses consist of having quality control test points. And the areas typically looked at are the incoming corn, the processed corn in the slurry tank, and also processed corn in the fermentation tank. And dried distiller grains are also usually analyzed. There are time-consuming analytical methods which are traditionally used to analyze things such as moisture, oil, protein, and starch in both the incoming corn and also in DDGs. HPLC is commonly used to analyze things such as carbohydrates, acids, ethanols, and other alcohols from both the slurry tanks and fermentation tanks. To do both of these, a well-equipped laboratory along with experienced chemists are required. So here you may want to look for an alternative solution to these time-consuming analytical methods. Some of the advantages of near-infrared analysis is it's rapid and it's non-destructive. It's easy to operate and to maintain. There is no sample preparation required. And basically, it gives you a chemical analysis without the need of chemicals or a chemist. And in a single scan, you can analyze multiple components. It has good reproducibility, and it's very flexible, and analysis can take place in any working environment, whether it's in the plant, right next to the production line, or if it's in a lab, or it can even be used in the field, such as a corn on the back of a truck in a cornfield before the corn is even harvested. So examples of near-infrared applications for the ethanol process can either consist of a benchtop system, which is depicted in the upper left-hand corner, or an inline system, which would be more advanced, where fiber optic probes are placed in the areas of test interest to eliminate the need that you would have with a benchtop system of manually collecting the samples that you want to scan. So for incoming corn, number one, in the delivery phase, in a single scan, for example, you can test moisture, protein, oil, starch, and any other traits of interest. You can also, at this stage, develop acceptance and rejection criteria and it can easily be tested before you will accept or reject that specific load of corn. You can also use this system to easily monitor suppliers, and you can grade them or give them a scorecard based on their performance, and also crop information can be utilized for process optimization. For corn mash, ethanol and carbohydrates such as glucose, maltose, multitriose, dextrin, etc. Then acids, which would be potential inhibitors, and glycerol can be tested throughout the production as well. So this rapid testing can be used for quality control, troubleshooting, and enzyme and supplement evaluation. So to summarize, near-infrared analysis in bioethanol production can aid in raw materials analysis, reaction input and material confirmation, can provide real-time and remote reaction and process monitoring, reaction optimization, endpoint or final product decision-making, product and co-product quality assurance, can reduce cycle times, and it can improve both quantity and quality output. Where do I begin? With the extensive brand options and different types of infrared systems available, some of the key factors you may want to consider include: what is the optimal instrument and sampling device for my specific application needs? Who will serve as the chemometrician and spectroscopic expert to build and maintain reliable methods? How can I prove performance prior to making a capital investment? How do I build a sufficient library of representative samples and good quality primary data to build the models? Who will manage the system and make improvements and adjustments once the system is in place? And lastly, user-friendliness. Ideally, I want a system that should be operable by any plant operator. So some typical spectrometers that are on the market that you may want to consider would be from manufacturers such as Bruker, PerkinElmer, Thermo Scientific, Agilent, Foss, Unity, Zeiss, just to name a few. They have different versions or different brands out there, and then they focus on either Fourier transform, dispersive, diode array, and then they have different spectral ranges. So there is a lot to consider out there. So to eliminate some of that hard decision making on what type of instrument or who do I approach, QTA is not bound with one instrument manufacturer. We're not an instrument manufacturer. We are a service provider, and we can work with most instrument manufacturers out there when we determine what the best instrument is for your specific application. For expertise for algorithm development, always remember garbage in, garbage out. And what I mean by that is you need to select the right reference methods and the right laboratory that is accurate, reliable, and is reproducible for results to get good primary data to start off with. You also need to understand the standard error of prediction and to determine where your needs lie, so you have a plan in place of where you're at with your primary method and then your expectations for where you'd want to be with a near-infrared system. You also have to design the sample matrix. You have to truly know your materials and know the limitations, and you need to start with real or pure samples for the initial development. Some challenges with near-infrared to address if you already have an existing but outdated system include: do you keep existing algorithms, or is it better to start from scratch? Are your old algorithms easy to be transferred from the older system into a new system? And are the algorithms even reliable and worthy enough of transferring? If you have more than one plant or facility and near-infrared system, do you want to consolidate systems and use one system and one standard corporate-wide? If so, you need to consider something like a centralized server for models to be housed. So for an optimal near-infrared system, an internet-enabled system with a centralized processor and database should be considered. This will allow for multiple near-infrared instruments, regardless of the location they are in around the globe, to pull from the same model. So there will be no lab-to-lab or location-to-location bias. You also want to consider the best technology out there. And QTA holds several patents in the IR space. The technology behind infrared is chemometrics. And my co-presenter is Dr. Ching Tseng. And one of our patents is actually chemometrics, which is the technology for QTA's unique operational strategy with features you will not find anywhere else, such as the ability to successfully share robust calibrations on multiple instruments, regardless of the location, regardless of the time, regardless of the light source. And you do not need to worry about adjustments or drift. So the internet use allows for remote advantages, including the centralized model that I'm referring to, along with the model development, updating, instrument performance monitoring, and issue resolution. Additionally, data is transferred and model predictions are conducted in real time, and the storage and distribution of data is automatic. For example, if you have a smartphone and you have a QTA system in place and you're not on site, you can log in and you can see the results of your scans in real time, regardless of where you are. So the idea behind the centralized modeling is the simplest analyzer with a smart brain. So no individual model development management is required. Models do not need to be adjusted locally, and there is consistent prediction, even with different instruments at different locations. There are no technology limitations, and models are updated simultaneously to eliminate any concern of which model is the latest and which one is being used and pulled at different locations. Some of the key benefits of QTA is a versatile system. It's one device for many grains, materials, and traits. It's a smart system. It allows for high-tech analysis without the high-tech or high-cost operators. It can be used in the field. It is quick, easy, non-destructive, and rugged. Like I mentioned earlier, it can even be placed in the back of a truck going out into the field to analyze the corn before it's even harvested to make sure it's at the optimal harvest conditions. The centralized network. This ensures consistency, remote monitoring, and also remote method development. In the information access, it's real-time information regardless of the location you're at, and it's affordable. It's fee-based, and there are no capital investments required. To give an example of the chemometrics model conditioning, this is just showing a variation between different instruments of the reading of oleic acid in canola looking at 15 instruments running 3 samples in duplicate. The red line shows how the predictions would rank without chemometrics. And then applying chemometrics, the blue line shows the results there. So as you can see, the performance, regardless of different instruments, is very reliable and reproducible. you will find the same trend looking at a period over time. So this is looking at the same instrument, 12 days, 12 different days over a 6-week period, 3 samples run in duplicate each day. And you can see the difference in the red line, which is the predictions without applying chemometrics, and the blue line with chemometrics, and can see the same trend. We've also done this study on various light sources with the same trending, and also with temperature changes ranging from 5 degrees to 40 degrees Celsius, and applying chemometrics again allows for repeatable data. So QTA has also participated in the soybean quality trait program for 10 years. What we're showing here is a protein round-robin sample or check sample where 17 labs participated in this. The blue bar is the range of results, and the green square is the wet chemistry mean, and then the red X is the QTA result. We've done this for things, this example is protein, but we've also done it for oil and moisture and other traits that are of interest in soybeans. And as you can see, the QTA result in each case matches or is very close to the wet chemistry mean. So now honing in on ethanol analysis. I know that there are a lot of numbers and words on this slide, but it will be provided afterwards so you can review it in more detail. But what I want to show here is in different stages along the production, from the delivery to the hammer mill, to the slurry tank, to the fermentation tanks, and also the co-products. QTA can be the one piece of equipment that can analyze for all the traits listed on here and any more that you may have of interest we can discuss. So things such as starch, protein, oil, and moisture. In a single scan taking less than 2 minutes, you can have all of those readings. Also, we have listed the R-squared value and the standard error, and that is according to the reference method that is listed in the right-hand column. So this should just give you an idea of how all-encompassing the system can be for you. The same is true for corn DDGs. So things like fat, protein, L value, moisture, ash, and fiber, dry base, can all be analyzed here. And the same with corn oil, free fatty acids, moisture, insolubles, unsaponifiables, MIU, and soap. With that, the QTA process starts with our clients completing a wish list. And what the wish list includes would be something looking like the charts that I just had up before, what materials you're interested in testing, what specific traits, what your range would be, what kind of accuracy you need, what your primary method is. Once we look at that wish list, we ask you to provide 30 samples along with your primary data for all of the traits of interest. From that, we'll provide you with a complementary feasibility study. And once you want to proceed, we work to develop the algorithms for you, which are custom to your specific production and industry and process. And then we'll move on to do a validation. And then from there, we manage it 24/7, 365 with both client and technical support, US-based, live. So we also handle the maintenance. We maintain all the algorithms. At a minimum, we do an annual validation, and we can do it more frequently if needed or if requested. And for some industries, we do participate in a regular check sample program. It is a great system to consider. It really takes the work out of your hands so you can focus on other things. So in summary, QTA, or quality trait analysis, provides tiered solutions to develop, implement, and maximize the benefits of infrared technology to your operations at your location. We work with high-quality data from robust methods so you can measurably increase the value of your finished product anywhere in the supply chain, improving process yields and also increasing profitability. We offer optimization of existing infrared applications. We also offer implementation of new systems tailored to your specific needs. We also develop and maintain the methods. We also consult on special infrared projects. So with that, that concludes my portion of the presentation, and I would like to open it now for any questions you may have.
Thank you, Karen, for that very informative and interesting presentation. Our first question today is, what are some challenges of inline model development?
Hi, is Ching on the line?
Yes. Can you repeat the question? It's kind of the on-off, so.
Yes. What are some challenges in inline model development?
Oh, yes. Okay. For inline application, it's kind of a little bit different from the offline. For offline, you have a kind of static sample with some more controllable condition, so it's easier to handle. But for inline, because there are couples, one, the environment is kind of has more variables, and also your sample point is maybe a decision point. You need to decide where you need to put your sampling point. And also for the sampling point, either you have to modify your kind of process to install the kind of a probe or monitor system over there. So how can you define whether the sampling point is the correct one you should put in there, and what kind of either you need to put a fiber optic probe over there or kind of a bypass to monitor. So there are lots of the challenges, and also whether the sample spectra you collect from there is good spectra or bad spectra. So how can you control this? So these are kind of challenges for the non-experienced person. And of course, this is also a big investment for a company. So before you start inline application, how do you know whether it's good or not? So if you spend money over there and you find it's not the case you need, then you lose your money. So there's some challenges over there.
Thank you. Before I ask my next question, I would like to remind everyone, if they have questions, please go ahead and put them in the queue, which is under questions on your webinar panel. Our next question today is, do you have preference on NIR instrumentation? Would you like me to repeat the question?
Wait a minute.
Ting, did you hear the question?
Yes, can you repeat again, because it's kind of on off.
Do you have preference in NIR instrumentation?
Oh, okay, the preference. Okay. Just like what I said, different condition or different environment, you may need different technology. Just like some parameters you need, just like very general, just like oil or protein, moisture, something like that. Those, if those are just the basic information you need, then you don't need a very high-end, more advanced near-infrared. You can just use a diode array. It's cheaper, rugged, and for some more trade, if you need, then you will need like Fourier transform near-infrared. And in some cases, you just need, just like if you want to monitor only one or two parameters, it may be even cheaper in near-infrared. So actually, for QTA, we normally ask the customer to provide their vision list, and according to our experience, we'll define what kind of instrument is best for their application and get the lowest cost. So, of course, that's also what I say, it's kind of challenge for the user, how to pick the right instrument to use. That's what we are taking care of. So for me, whether there's preference for the instrument, it depends on your application. So there's no specific vendor. The vendor we can use, or some you may already have your system over there, just need to optimize the application. You can help also. So there's no specific preference for the instrument vendor.
Okay, thank you. Our next question is, if I use NIR for analysis in my ethanol production, do I still need to keep my lab with all of the existing lab equipment I have?
Yes, it's a good question, because the reason you like to use the near-infrared, that's because you want to reduce or kind of reduce the cost or the frequency of your primary lab, or you may not need so many chemists in your lab. But can I just completely get rid of those? My question is no. If you already have those, you had better keep it in your location, but you can reduce your frequency of measurement by the primary. But because sometimes you still need to validate the NIR method by the primary. Just like if you have a process change or you have a material change, you like to validate, or if you don't feel, sometimes you don't feel confident, so you need to, at the beginning, you may validate with the primary in more frequent situation, and after you build confidence, you can prolong the kind of the validation time, or just like do your primary either weekly or monthly, something like that. But if you don't have the primary lab, then that's fine. You can send a sample out for the test, but the frequency of the validation, it depends on your confidence level. You can have more frequent at the beginning and kind of do it less frequent after you have the confidence built up. Okay?
Thank you. Our next question is, what are the detection limits for acids in fermentation? For example, a 0.01% change in acetic acid is extremely important to health of yeast.
Can you repeat again?
What are the detection limits for acids in fermentation?
Okay. Just as the near-infrared is a secondary method. The secondary method, the limit of detection, it depends on how accurate is your primary method. So, of course, all the methods have its standard error. So, when we develop a method, if you arrange just like it, maybe from 0.1 to 1%, then the standard error may be just 0.1%. But if your kind of range is from 2% to 50%, the standard error can be higher. So the limit of detection, normally we define it as about 3 times of your calibration standard error. So normally we started with a feasibility study, and you will need to provide us a set of sample with the primary data. Then we build a kind of the draft model and to see what's the standard error of this method. Then from this method, then we define kind of a limited detection. It's 3 times of the standard error. So if you want to know the acid, just like in the table, in the presentation, there's a table. It shows that each method it has its SEP, and you can times 3 times of the SEP. That's the standard error of the method. So you can see there's the DP2, DP3, and there's also a kind of acetic acid over there. So from the table, you can see about how much is the limit of detection.
Okay, thank you. Our next question is, since QTA NIR has to use the internet, can I still do the NIR analysis if my internet is down?
Yes, it's a good question, because at the beginning of QTA, customer always concerned, how about, because you completely rely on the internet and everything is on the server. So if I lost the internet connection, then I cannot use that at all. That's right. At the beginning, we had this issue, so we always has a kind of using the phone line as the backup. But right now, we have another technology called queuing box. And in the queuing box, we have a simulate server over there. So once internet is done, then you still can analyze, and it still can produce the predicted result, and the data will still store temporarily on that queuing box. But after the internet reconnected, then it will synchronize with our server. So everything still go to the server. So we keep everything in fresh. Also the data is also at the center server. So if the management want to see what's the result, or if you want to download the result, you can still go to the QTA server to get the result or the historic report. So queuing box is our solution for this internet connection issue. That's what we just developed recently.
Thank you.
Any other questions?
Yep. My last question is, why would one desire QTA services when instrument vendors make the NIR implementation so simple? Let me repeat that one more time. Why would one desire QTA services when instrument vendors make the NIR implementation so simple?
Yes. Normally, the near-infrared vendor try to make it as simple as possible, so the user can just analyze with a very simple way. But the problem is many users, if they don't have the experience of the infrared, and you may build your own calibration model or use a kind of model provided by the instrument vendor. But near-infrared or chemometrics, it's not like HPLC. You separate the peak and use a standard to calibrate. Near-infrared, because you don't do any separation, so the peaks, they overlap each other. You need to use the chemometrics software to resolve and to resolve the issue, build a model. So if some metrics change, then your prediction may change. But if you don't have enough experience, you may be scared. some of our customers, they purchase the NIR instrument by themselves and use them for kind of couple months. And once the prediction they do kind of the primary analysis again, they find, wow, it's up so much, it scales them away. So their instrument become a paperweight because they no longer trust the result. But they don't know when they can trust or they cannot trust. That's the issue. That's why QTA is doing this kind of service. We do everything for the user, so the user for themselves, they don't have to worry about whether the result is trustable because we maintain the model, we validate. When something wrong, we resolve the issue, we find what the cause, why the result is, and we can kind of remedy it right away. So the user don't have to worry about this kind of issue. So of course, instrument is just like a tool for you, but how to use the tool right, that's the most important. So that's why QTA's role is to make sure you are using the tool right. Any other question?
That was our last question for today. Thank you for all of your insight, Dr. Feng. So that concludes our webinar for today. Thank you everyone for tuning in to our webinar, and thank you Karen and Dr. Sang for your expertise and presentation today. I hope everyone has a wonderful day.
Thank you.
Thank you. Bye.
Bye.
Bye.